So we can get to the analysis tools in two different ways. We can use the right mouse button on the part, as shown here on the left, and then we can go to the analysis tools option, and then we can list out all of the analysis tools to be used on that particular part. We can also use the tools drop down menu and go to analysis tools, and then that will give the same list of tools available for use in an analysis. And these are really diagnostic tools to try and understand if there are problems in the geometry, and give us some indication of some of the properties of the geometry in order to help us potentially with some of the repair and fixing of the geometry. The repair tools can also be accessed from the tools drop down menu. So we go to tools, and simply it's the one above the analysis tools and repair, and then we see all of the repair tool options available here. Now these options can be conducted on both frozen or active bodies, so it doesn't matter whether the status or the state of the particular body. And we have a number of different types available for hard edges, edges, holes, sharp angles, slivers, spikes and faces, and we'll show you some of the examples in the following slides of repairing some of these types of problem regions. So in terms of automation and automatic detection of these problem areas, you will see that when you select one of these particular repair tools, you will find the design model will list out all of the affected regions that could be a problem in relation to that particular tool. So if in this case, we can select a repair edge, which is so this is just the command which is appended to all of the previous commands into the tree, and for this repair edge, it will then automatically detect and list out the issues associated with the geometry in question. So what we can see here in the details view is all of the edges in this case where we have potential problems. So edge 1 and the length of the edge and a potential repair method. Subsequently edge 2, edge 3, edge 4, etc. So it's listing out all of the potential problematic geometric entities, and also some a detail in terms of the length of the edge, but also the method by which to repair that particular problem as well. So this is an initial suggestion of how to repair it, but what we can do is we can highlight each of those particular problem sections just by selecting it, and it will highlight it in the geometry and show us where that edge is. Once we've understood where that particular problem is, we can make a decision on how we should treat that geometry. It may be important to retain that particular edge, for example, or it may be not unreasonable to remove that particular edge. So at this point, we're making a decision on whether this edge is of particular relevance to the simulation or not. But if we remove it, we can then choose to perform one of the repair options. But if we want to keep it, we can opt to basically do nothing on that particular edge and progress with all the other identified edges. So we will propose the particular cleanup method for that particular entity. So here we can see we have edge 1, we have the length of repair method, which is suggested as vertex connect in order to remove this particular edge. But we have lots of different options available to perform the repair. And as I mentioned, we also have the option to not repair as well, if that particular edge, for example, was of particular use. But once we select the particular option that's listed in this drop-down menu, and we can do that for all of these particular identified edges, we can then click generate or hit F5 in order to go around and have Design Modeler automatically clean up all of those edges using all of these different methods for each of those edges. We can't do it one after the other because it will all be done in a group after we've done the separate selection and after we've hit generate. So here's some examples of some of the repair options. Here we can see we have 3 faces, but we have this green edge here which only extends up to this particular point. And if this is a relatively small edge compared to the sizing of the model, so we can see here some filtering on the sizes of the edges for capturing for problematic edges. And if this is deemed as within that range, we can try and treat this particular edge by removing it. And what we're actually doing is removing this vertex position, because we'd have to place a mesh node at this vertex position where this edge terminates. So what we're doing is we're essentially choosing an option as an edge merge as a repair method, and then by doing that we're merging it with the adjacent neighbouring edge here to remove this vertex position here. So then we end up with a continuous edge all the way up here, and we're removing that segregated short edge. Another option is to perform a vertex connect to remove the short edge. So here we can see the option vertex connect. So here we have 4 faces which are essentially staggered as far as the intersection of the 2 pairs of faces. So we end up with this very short edge between these 2 perpendicular edge locations. So to remove it, what we can do here is we can perform a vertex connect in order to snap this vertex on the left and this vertex on the right together. So we end up with the 4 faces and a single vertex in the center that's used to connect all of the 4 faces together. Another tool is the repair hole tool. So just what we do is we create a repair hole command. We choose some limits for the sizing of the holes, and allow Design Modeler to search through the model and find all of the holes that lie within those limits. And here we've got this example on the upper left. We can see a solid body with 3 holes in it, and all of these holes have been identified and are listed here. Once we create a command, once we find these problems, we can see hole 1, hole 2 and hole 3 listed, and the sizes of those holes, and the suggested repair method, in this case fill the holes. And if we leave it all as default as fill holes and then hit generate, it will then fill all these holes in here. It's worth mentioning that we could actually repair these holes by using a face delete command, by selecting all of these internal faces and hitting face delete, and that would also delete those holes as well. But this is quite a useful tool if we had, for example, hundreds of holes, to automatically find holes and fill them all in one operation. The example on the bottom of the slide is for holes in the surface body. So it's basically like a surface patch that needs placing over this particular region in order to fill it over and provide a cap in order to complete the surface body. So that's done with the repair hole tool, and here we can find the problem areas, and the repair method that's been suggested is edge delete, but what we're going to do here is edge delete in order to repair the hole in the surface body, and then the hole has been removed by virtue of this edge delete option for hole repair. Next example is repairing of hard edges. Here we can see the hard edge on the upper left hand side that protrudes into this face. It doesn't go all the way across the face, but part way, so we end up with like a free end of the edge that resides inside the face. So it divides. It doesn't completely divide up the face, but it protrudes part way into the face. So this is defined as a hard edge, and we can simply remove that with the hard edge option, with the option visible bodies. So it will only be affected on the bodies that are visible, and that's done with simply an edge delete operation as the repair method, and that will simply remove that edge from that particular face and body. So here we can see on the right hand side the hard edge has been removed. Down here we can see the seam or remove seam operation, or repair seam operation, where we're selecting and identifying the seams that are in the body. Again we have some filtering for seam width, for min and max for the seam width, and we can select the operation tool. Here we've got automatic and do not repair, and automatic will attempt to remove this seam. Here we can see that the seam has been removed. We can also opt for repairing of sharp angles. Again, it will search through and look for all of the angles between, in this case, between the minimum and maximum angles, in this case between 0 and 20 degrees. In this case it's found an angle which is 1.6 degrees, and the default operation is to perform a face merge, which will merge the face out with a neighbouring face in order to avoid that sharp angle. Having these sharp angles would cause problems with the surface mesh and a deterioration of quality in the solution as a result of the poor quality surface and volume mesh. So it's desirable to try and remove these geometric features as has been done in this example here. And in this case we have a sliver face, a continuous thin face across the length of the neighbouring faces, and again we can identify that with some limits here, 0 to 3.5 mil as the min and max width respectively, and choose an option for removal, automatic, edge connect, face merge, or do not repair. In this case we selected automatic to remove this particular sliver face, and it can be seen on the right hand side here as removed. Another example of repair is repairing of spikes. So we can identify these spikes again with a repair spike tool to try and find it. Again, we've got the filtering tools and some options for repairing to remove these particular problematic areas of the spikes that can occur, and basically snap these two entities together so we don't end up with that gap that forms the spike. Now we can also repair small faces, so we can look through the model, look for very small faces, again with min and max limits for the face areas, and if we identify small faces that have a face area within those limits, we can then attempt to repair that, or perform face merge, or don't repair, in order to remove that geometry from the model.